So this lesson, we're going to start writing equivalent representations of trigonometric functions. And so to do that, we're going to use the identities that we derived a few days ago. So here they all are. So this first lesson, we're really going to focus on these top ones. So the reciprocal, the quotient, and the Pythagorean identities. And so one thing that is kind of difficult for students when they're learning this is just to know where to start, know when to do what. And it's early, like it's probably going to be a while before you know those things. But I'm just going to make a few notes. You can write this on the back or you can squeeze it in the margin. But whenever there's multiplication and division or some kind of combination of multiplication and division, like on example 1 and 2 and 3, a good place to start is to write everything in terms of sine and cosine. These are options. This is not necessarily what is going to work, but they're just options, things to try if you don't really know what to do. You can't see what's going to happen on the problem. Another thing is whenever there is a squared term in one, or possibly two squared terms added or subtracted from each other, you're going to want to use these Pythagorean identities. All right. And so a lot of times you do kind of end up with this crazy looking thing where you have a fraction on top of a fraction, but don't worry. A lot of times once you get something like that, the answer kind of develops. And anytime you want to divide by a fraction, you're going to multiply by the reciprocal, and you'll see that a few times today. Okay, so on example 133, this is the way it's worded on the on the AP test. Sorry. So what we're going to do on this, since we have a combination of multiplication and division, we're going to go ahead and write everything in terms of sine and cosine. And so if it already is a sine of x, we're going to leave it that way. But then for secant squared, I can write secant of x as 1 over cosine of x. So secant squared of x is going to be 1 over cosine squared of x. All right? And then cosecant of x, I can just write as 1 over sine of x. All right, now that looks kind of crazy, but what we're going to do is write it as all multiplication, where the numerator I'm going to leave like it is, except because I have all these fractions, I'm going to go ahead and write sine of x as sine of x over 1. That's going to be multiplied by the cosine squared. So I didn't really change the numerator, but the denominator, to divide by that, I'm going to multiply by the reciprocal. Okay, and then whenever you're multiplying fractions, you just multiply across the numerator. So sine of x times 1 times sine of x is going to be sine squared of x. And then you multiply across the denominator. 1 times cosine squared times 1 is cosine squared of x. Now, I want eventually to just write this in expression involving tangent of x and no other trig function. All right, so when I'm looking at sine squared of x over cosine squared of x, it looks a lot like this tangent quotient identity. So if these are both squared, it's just going to equal tangent squared of x. All right, and I have done what they asked me to do in the directions. I rewrote that as an expression involving tangent of x and no other functions. All right, let's look at example 2. Example 2 tells us to rewrite g of x involving secant of x and no other function. Now, does it matter? We're not going to start with a secant, just like on the last one, we didn't start with a tangent. Just hopefully in the end, we can get it there. So I'm going to start off the same way. I'm going to write cosecant and tangent using only sines and cosines. And so for cosecant, I can write it as 1 over sine of x. For tangent of x, I can write it as sine of x over cosine of x. All right. And then because these are a multiplication, or this is multiplication, and I have a sine in the sine of x in the numerator and a sine of x in the denominator, they can cancel. And then when I multiply across the numerator and across the denominator, I'm left with 1 over cosine of x. And I know that 1 over cosine of x is secant of x. And that is what I wanted to be left with. So I am finished. So that one was slightly easier than the first one we did. All right, and then example 3, we're asked to rewrite it as a fraction involving powers of cosine and no other trig function. All right, so I don't want you to feel like we always write in terms of sine and cosine. It's just that's how these problems are working out. For a tangent, I'm going to use that quotient identity and write tangent of x as sine of x over cosine of x. For cosecant, I'm going to use the reciprocal identity and write it as 1 over sine of x. All right, and then just like I've done on previous examples, I'm going to take the numerator just like it is and multiply by the reciprocal of the denominator. Okay, and I'm going to multiply across the numerator and across the denominator. Now that really hasn't made it look any better than the original one, and we definitely haven't finished because we have sine and cosine of x, and we want to only end up with cosine of x. So let's look at our identities. We need to find an identity that we can rewrite, or we can rewrite sine squared and turn it into a cosine or a cosine squared, or it could be multiple things with the cosine, but we need to get rid of sine and make it cosine. And so what we're going to do is use this first Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1, but we're going to manipulate it. We're going to basically solve it for this numerator. All right, so I'm going to do it above. So the identity that we're going to use is this. But I want to solve it for sine squared of x. So I'm going to move the cosine squared on the other side by subtracting it. All right, so anytime I have sine squared of x, I can change it to 1 minus cosine squared of x. So that numerator, I am going to change to 1 minus cosine squared of x, not theta, and leave the denominator cosine of x. And I've done what they asked me to do. I rewrote it as a fraction involving only powers of cosine of x and no other trig function. Okay. And then this example 4 is more kind of like a matching / multiple choice questions, which will also be on the AP exam. So ones like example 1, 2, and 3 are going to be on the fourth free response question, but throughout the test, you could have these trigonometric expressions on a multiple choice. And so we have 4 goals that we want to reach. So we're just going to start working the problem and see what we end up with. And so the first one, we have cosecant of x over secant of x, and we want to simplify it down to one of those 4 choices. And so I would again start off by writing these both in terms of sine and cosine. Just using the reciprocal identities. All right, then I would take the numerator and I would multiply by the reciprocal of the denominator. And when I do that, I'm going to get cosine of x over sine of x, and that is a straight identity. Cosine of x over sine of x is going to be cotangent of x, which is an answer choice, which is great. That's just going to be C. All right, for number 2, we can start that the same way we've been doing these problems, where we are just going to write in terms of sine and cosine, which will be perfect. We could, if you wanted to, instead, we could leave tangent alone and change cotangent to its reciprocal, which is 1 over tangent. All right. And so basically what happens is both of those tangent of x's cancel, and because we have 1 in the numerator and 1 in the denominator, so tangent over tangent is going to just be 1, which is choice A. And also, the more of these we do, you're going to recognize that anytime you multiply reciprocals, you are going to get 1. Just like with numbers. When you multiply numbers that are reciprocals, you get 1. The same thing happens with trig functions. Okay, so number 3 is not one I would expect you to know how to do before today. So what we're going to do is factor using the difference of squares. So when we factor using the difference of squares, we'll have our 2 parentheses, and we find each square root, and we put 1 with a plus, and we put 1 with a minus. And so the square root of sine to the 4th is going to be sine squared of x. And the square root of cosine to the 4th is going to be cosine squared. All right, and then if we look at our identities, sine squared of x plus cosine squared of x is always going to just be 1. All right, and so when I multiply that by 1, I just get the sine squared of x minus cosine squared of x, which is choice B. All right. And then this last one. So like I said at the beginning, anytime we have a squared term and a 1 or 2 squared terms together, it's going to be one of these identities. And so the identity with the squared term and the 1 that matches this is this one. And so I'm going to just jot it down so I can talk about it. I wrote it too far away. All right, so that was kind of terrible. All right, so I want that to look exactly like this numerator. So what I'm going to do is I'm going to subtract the 1 from both sides. And so cotangent squared of x is going to equal cosecant squared of x minus 1, which means anytime I have cosecant squared of x, I can replace it with cotangent squared of x. All right. And then even though this is the middle of the problem, that's not any answer choice that we have. And we already kind of know that this one is going to be D because we haven't used D yet. So even though it's not the beginning of the problem, we can still do what everyone seems to kind of like to do, which is write everything in terms of sine and cosine. So cotangent squared is going to be cosine squared of x over sine squared of x. And then, of course, cosine with square root of x on the denominator is going to stay that same. All right, and then I'm going to take my numerator and multiply by the reciprocal of the denominator. The cosines cancel out. We're left with 1 over sine squared of x, which, using a reciprocal identity, is cosecant squared of x, and choice D.